Innovative software needs innovative development. My name is Ulrich Bodenhausen from Vector Consulting Services. Welcome to my presentation at the Vector Forum. Let me guide you through my presentation. After a short introduction, I will talk about three topics. First of all, innovation due to complexity, resources, and efficiency. Secondly, innovation due to multiple development partners. And thirdly, innovation due to machine learning and artificial intelligence. I will then come to summary and conclusions. So what are the current trends? Autonomous, connected, electric, and shared. So in this presentation, I will not talk about the products itself. Rather, my presentation is about the changes in the development that are needed to develop these products. So what are the effects on development? So first of all, we see effects on product development mainly resulting from complexity, resources, and efficiency. In addition to that, we see effects on product development resulting from multiple development partners. And last but not least, we see effects on product development mainly resulting from machine learning and artificial intelligence. So let's get into more detail on these. What are the effects on development resulting from complexity, resources, efficiency? First of all, we see a rising complexity of systems. We have seen it already, and these trends will further emphasize them. We also see a growing amount of data in the context of product development. Once the data is corrupted, there's a huge effort needed to get it right again. We also see rising expectations of engineers concerning support of their work. And at the same time, we see limited availability of personnel, and due to that, we just require improved efficiency. On top of that, people expect ease of use and efficiency that fits to 2021. We are not in 2000, and things have changed in the meantime. So in product development transformation, there have been process frameworks like SPICE and CMMI, and they have guided the transformation programs for a long time. And this has been good. So there have been goals, there have been processes, there have been practices. But today's experience is that just doing more process management is not sufficient. We still need it, but it's not sufficient. Just doing more detail of processes, more process managers, more templates, more engineers to fulfill the process artifacts is not sufficient. We need something more. And with today's product challenges, we have a process-first philosophy, meaning let's first look at the process. So what do we have to do? And then how it is done. It comes to its limits. So let us look at an observation from numerous SPICE assessments. So every SPICE assessor knows, for instance, looking at project artifacts, when a certain tool is used and the tool is used correctly and well, then many of the artifacts are there. Example from configuration management. So you see here, if the tool is done well and the tool is correctly implemented and it's used, so many of these base practices are fulfilled. So what we see here, the experience really is, and this holds also for other processes, that a good implementation of a tool can significantly enforce and ease the adherence to the practices. So now if we have a look at the complete tool setup of a project, we see that this can be very diverse and complicated. We see DOORS, enterprise architects, we see the usual set of vector tools, Candela, Studio, DaVinci Configurator, Canapé, Canoe, VT System, and we see other tools, of course. And this tool setup is complex in itself, and it requires attention. And my statement is that many improvement potentials are in how these tools are working together. Of course, one could say, let's have everything in one tool, but let's face it, this will be not possible in the short term. So what we have seen in transformation so far we have transformation driven by a change of process on the one side, improvement of processes, assessments, methods, trainings. Then we have on the other side seen transformation driven by implementation of tools. We also see that the resources are very often quite different. So this will merge together to a transformation driven by seamless working environment. We have to improve the combination of process and tools. In order to achieve that, we need a bridging of the gaps between the tools. We also will see assessments, of course. We also see methods, but we need a seamless working environment. And the new role we see arising here is the seamless tools manager to drive this transformation in the short term. As an example from one of our consulting projects, on the left-hand side, you see the problems of a project in a task force mode. So you see there are many, many problems associated with data and the connection between tools. And you see also on the right-hand side, if it's a process, is a tool, and so on. So you see it's a mixture of both. And once such a data set is corrupted, it's not a question of just putting 10% more people in the project. This will not solve the problem. It's other magnitude. You need to automate it. You need to do something in order to automate the resolution of these problems. So the benefits we have seen from our work in this project, that the inconsistencies in the product data in an important project in the task force mode have been resolved by quick and automated solutions. Now let us come to innovation due to multiple development partners. So what do we need here? It mainly affects connected, somehow electric and autonomous. But the effects we see on the product development are the following. We see a fast increase of the number of development partners, and we see a huge need to coordinate them. We also see the need to specify the overall system. We also see the need to integrate and test the overall system. But I will focus in my present today on this first topic. So now we see a connected system. We see a car connected to an OEM backend. We see services in the cloud. We see the smartphone. We also see a connection to another car. So also there are development teams behind all of this. And how can this be brought together to develop one system? You need to coordinate all these development teams. So to achieve that and to guide that, there has been a working group from the VDA, Agile Collaboration. I've been part of it. The Volkswagen, BMW, Bosch, Conti, and other suppliers have been in it. And there is this freshly printed book out of this. It's really fresh. It's a nice book, and you can order it from the VDA. And the objective of this working group was to facilitate new forms of development partnerships between organizations, across organizations, not only belonging to one organization. To give you an example about the topic we have been talking about, software development by end parties on one system. So the user story is the following. As a client, I want to be more involved in the software design and the development of one ECU. Therefore, I want to work with multiple dedicated software development companies. So, and in this working group, we have defined several levels of collaboration. You see, there's a linked collaboration, there's an aligned collaboration, and there's a so-called combined collaboration. And there's a recommendation of the working group concerning, in this user story, the recommendation is to work with a combined collaboration. And in the book, there's a lot of information how this combined collaboration is characterized. To give you an example, I show you the collaboration planning. So we have defined roles that you can standardize across all partners to say, okay, we have a same understanding about these roles, and now let's talk about collaboration planning, you can put this picture on the desk and say, how do we want to do this collaboration planning? And you see a nice graphics, you can put on the table and you can discuss about, then you have a good basis for your discussion and improvement to your project's needs. So the benefits we have seen in a project that we have done before this book was out. So with the coordination and management of all collaboration partners, a significant improvement in velocity and product quality could be achieved. And this has been done in an infotainment project, where of course, infotainment has many partners for speech, the maps, the navigation, and so on. So there are many partners coming together, and the ideas that finally have been gone into this kind of book have been shown these improvements in a VCS project. So now let me come to innovation due to machine learning and artificial intelligence. This applies mainly to autonomous, somehow to connected, somehow to electric and shared, but the application of AI is really for autonomous driving. So in context of that, of course, you have safety of the intended functionality, so SOTIF, a new standard, and agile development, but I will focus on artificial intelligence. What is it? What is the change? So the change is inductive learning instead of programming of functions. I have depicted here a deep learning neural network. You can also take other approaches, but what they have in common is the following. You are learning something from training data, and you don't need to program these functions by yourself. So you have a set of training cases that you use to represent to your learning algorithm, and you have a set of test cases that you use to finally check out how well is it doing. And by this learning algorithm and this training cases, you do some adjustments of the internal parameters. So what is the difference between classic software development and AI software development? So let's start with what they have in common. Both need some kind of implementation. So also AI software does not fall from the tree. You need to program it, you need to put modules together, you need to make sure that this implementation of the code itself is correct. For classic software, you then, if you have coded this, you after compilation, you take the result of the compilation, and this is directly used. For AI software development, you then take this result of this compilation and apply this learning algorithm. You take training examples and you repeat until these internal parameters have been adjusted by this learning algorithm. And with AI, the result of this machine learning process is used. It sounds like a small difference, but in fact, it's a new philosophy. It's not defining a function, it's defining a learning algorithm based on training data. So these changes will become severe challenges. Can become severe challenges. In many cases, the problem is in the details. However, mastering this is necessary to enable innovations that would not be possible without. Now, think of speech recognition. I've been working on it 30 years ago, and speech recognition would not be possible in today's form without artificial intelligence, and see how far it is used. In America, about 30 million people are using speech recognition in cars at least every day, in cars only. So how does an AI development circle look like? First of all, you have the definition of the requirements for the AI-based subsystem. Then you define the requirements for the data collection. You collect the data and you label the data and assign to training and test data sets. This is what I call the outer circle of AI development. Then comes the inner circle, and this circle is really, really repeated very often. You set up an AI learning model and confirm the correct implementation. You train the model with the training data. You run the AI model on the test data. You analyze the results, and then you define the improvements. I've done it for 5 years of my life, and it's really demanding many, many cycles. The benefits of this is that, for instance, if you transport this to an assessment model, that we have done it for Vector Consulting Service. So it's like a plug-in to ASPICE. And so with this assessment model, we can identify also process improvements and development improvements for an AI-driven project, as we have done for an UI project. So and let me come to the conclusions. So innovation needs innovative product development. 5 messages for you. ACES products need a massive transformation of software development. First of all, the paradigm for change is changing. Processes, tools, and methods need to be improved as one entity. In this context, new roles and tasks become important, like the seamless tools manager. Secondly, there will be a need to master extensive collaboration between multiple parties. On top of that, AI software development is the combination of known challenges of classic software development plus a new discipline of mastering data and learning from this data. However, they are necessary to enable innovations that would not be possible without. Vector is driving this transformation based on the combination of tools, software, and consulting in one company. Thank you for your attention. I'm now looking forward to your questions in the question and answer session. Thank you.